Hello and welcome to this video. Here we'll be looking into factorial notation and evaluating the 5 choose something or n choose some other number. We'll be working in depth about the to learn about the definition of these notation where you got the combination numbers here. So let's answer this question. So what 3 choose 2 means how many ways are there to write two terms where you got two terms multiplied by one term. So altogether, let's say we got a and b square, or uh, let's say in this case a and x. So if that coefficient 3 choose 2 would help us answer this question. What's the coefficient of x squared? You would say, well, power is 3, so we're looking down this row here. Power of the bracket is 3, and power of x is 2. So it's going to be 3 choose 2. Okay. Now, why could it be also 3 choose 1? Because you could say I'm taking a to be 1 and x squared would be the other term. So this is evaluating how many ways are there to write a times x. So you could have written it three ways. That's why there are three. The answer is three there. Now we need to understand and evaluate these without a calculator at some point for small values of notice 3 choose 0, 4 choose 0, 5 choose 0 are always 1, and on the other side 3 choose 3 is always 1, 4 choose 4 is always 1, because there is no other way of writing. For example, if your only term is just x power of 4, there is no other term to multiply it by, so it's rearrangement that you counting the rearrangements. This is what these numbers telling us is still just the one way of writing x cubed, like x to the power of 4, because if I swap this x with this x with this x, you can't distinguish them. All right, so in this next part we want to find the coefficient of x squared in this expansion here, where you got b times x. Okay, so what do? We're going to say 9 choose 2 and multiply it by bx raised to the power of 2. All right, so what we do is we say we're going to write 9 choose 2 bx raised to the power of 2, and well, a is a constant that it may be a number, a to the power of 7, and the rest b should be a number, so you evaluate them. So the final coefficient, the final answer, we will deal with what that number is in a minute, but I'm just trying to make you understand is that once this ax is raised to the power of 2, power of a, it has to be the complement of 2 that will add up to 9. That's why we choose 7 there. Right, so get used to the idea of finding the complement there. So in the next term here, it's a plus bx all raised to the power of 5, and we're looking for the x cubed term. So if x is cubed, b is also cubed. You write that like so. Then you think to yourself the coefficient has to be 5 choose 3 or 5 choose 2. They're both the same, they're symmetric here on the table. 5 choose 2 and 5 choose 3 are the same thing, same number. And what's the power of a here? Well, 3 plus what will add up to 5? This power, remember we said all the terms have to have powers that add up to 5. So complement, you say 5 minus 3 is 2. And like so. So the last term here, you're looking for coefficient of x4. I must say the coefficient, you take x cubed and the coefficient will be just 5 choose 3 here, b to the power of 3 and a squared. This is the coefficient in this term here. Coefficient will be 9 choose 2 b square and a to the power 7, and then you factorize the x square out, because we're just talking about the coefficient. You just factor the x's out. So in this case, finally, x to the power of 4. That means dx, all of it is raised to the power of 4. We will have 10 choose 4. We write it like so. And finally, a will have to have a power of what? 10 minus 4 is a 6. Therefore, if we rearrange it and factor the x to the power of 4 out, we will still have inside the bracket 10 choose 4b to the power of 4, c to the power of 6. Alright, so these are the coefficients. Alright, so let's go back and notice that blue and red line there. Alright, so those are exactly what I said anyway. So now we are evaluating none, and we're looking for factorial notation. We're learning about factorial notation. I'll give you a hint already. This sign exclamation mark, if I say 3 exclamation mark, this is called factorial. Okay, so if you haven't heard of it before, uh, some Americans call it three bang. It's a factorial. Alright. So the question here is that these letters A, B, C, D, I've color coded them so that you recognize them as different distinct letters, okay? Different letters, and we want to know how many ways are there to rearrange these five. Okay, so five, you say the first, uh, let's say you've got five choices, 5 letters. What goes in the first, first space here? We have 5 choices, so we write 5. Then for the next space that we need to fill, we got like 5 spaces to fill, isn't it? So the once we taken any one of them, let's say we took E out first, then how many letters we left with for the next space here? We left with four of these letters to choose from. Once we taken, like, let's say we took B out of those 4, so for the third space here, we left with 3 for the. All right, so we, let's say we took D out, so we only have 2 spaces left and 2 of those letters, so we have 2 to choose from, so we times it by 2. And once you've taken that one of them out, then you are only left with the last one anyway, so timesing it by 1 wouldn't change anything, and we don't want to count it more than once. All right, so this is, when you times these numbers up, you actually end up with 120. There are 120 different ways of writing, rearranging the order of these distinct letters. I'm not going to sit there and show you one by one. There are 120 lines, so take my word for it. If you don't trust me, just take, I don't know, 3 different objects and start rearranging them. Yeah, sorry, 5 different objects. There are 5 objects here. So this factorial, what we just did is we evaluated what factorial means. Factorial, we just evaluated 5 factorial. You can go ahead and find this factorial button on your calculator as well. You will find it in the Casio FX 115 that I have. It's uh, it's actually under the setup mode button here. You have to press shift and X factor is the in the second menu. So I'll make another video to show you on how to find it with the other calculators. But for now, we're gonna evaluate them without without the calculator anyway. So I'm just gonna rub this off and show you the next section. So what we did is that we evaluated 5 factorial. So that's n factorial means n times the number be smaller than n. They have to be integers. They cannot be fractions or decimal numbers. Okay. So now let's say we have A, B, C, D. How many ways we can rearrange these 5 objects? Well, there is no way to distinguish between the A that are colored in red, is there? So we have to cancel away those two that are exactly the same. This is still five objects, so we evaluate 5 factorial on top of the fraction, but we canceling away the fact that we are not able to distinguish those two the a's. Those a's are the same. All right. So those actually we divide 5 factorial by 2 factorial, we get 6. And so we just figured out what this notation means. All right. So we said that because in this 2 here is the number of objects that are exactly the same. All right. I'll tell you what that R stands for. It's actually, it could have been just n factorial R divided by factorial. So the next thing is, now this is what is applicable to binomial expansion. So let's say you've got 5 objects. A is indistinguishable from A, and B is indistinguishable from B, and you want to see how many ways there are to rearrange them. Now, this is a crazy method. I've gone ahead and shown you how many rows there are of rearranging them. You see, none of these rows are exactly the same order. So you can sit there and look at it for a while, and you realize they're all different. So don't do this in the exam. This is crazy. What you can do is to now find how many rows there are. You say 5 factorial divide by 2 factorial, because I have two objects that are the same, and times the denominator by 3 factorial. That's that's why you're gonna get 10 here. Now, do you do you see why we do the cancellations here? Because and if you think about it, we are really looking at like expanding of this is a plus b raised to the power of 5, and we are finding the coefficient where you got a raised to the power of 2 and b raised to the power of 3. Okay, so this coefficient will be a 10. If you check your Pascal's triangle, on the fifth row, when you got a power of 2, you'll get 10. Also, it's symmetrical, so if you had b to the power of 2, a to the power of 3, this is the 10 is coefficient of that as well, because well, it's the same calculation. All right, so this is actually the coefficient. This is the binomial coefficient. What we did is we set n to be 5, and r is one of those powers. It doesn't have to be 2, it can be either 2 or 3. If you put a 2 here, then 5 minus 2 would be a 3 factorial. And if you chose r to be 3, then you get the same answer. You would have just 2 factorial first, and then 3 multiplied by 3 factorial in the denominator. 5 factorial would be on the top. Okay, so we just expand, and why did we bother with that? Because sometimes you will be asked to calculate things by, and you just have to use your knowledge. You're a mathematician, and you should be able to answer these questions. I've went through this example here, and I'm not going to explain that here. But do have a go at this exercise. This exercise is, I've written these questions on the Word file here. There for you as well. Pause the video, have a go, and then I'll explain it. So, I hope you've tried it. So, without a calculator, evaluate 6 factorial. So, just write 6 times 5 times 4 times 3 times 2 times 1. Now, I'm here showing you what to press for this is for the calculator FX. If you have a FXCG50, these options, this process will work for you. If you don't have that calculator, don't be looking for this option. You probably won't get the right answer. Like, you don't have a menu called run matrix, don't worry about it. All right, so this you sorry, yeah. So once you've written 6 times 5 times 4 times 3 times 2, This is the answer here. Now, without a calculator, evaluate 6, choose 3. So now this is what you would do. You would just say 6 choose 3 involves writing 3 in the denominator and then saying 6 minus 3 is what? Factorial. This is also another 3 factorial, isn't it? So that I need to evaluate. So I write 6 times 5 times 4, right? And then this 3, okay, I know the next number is 3 times 2 times 1. What was 3 times 2 times 1? It's 3 factorial. I'm going to keep it like that because I've spotted I have a 3 factorial in the denominator, don't I? That 3 factorial there cancels this 3 factorial. And then I can write that other 3 factorial. Its expansion is 3 times 2 times 1. All right. So I didn't bother writing after that 3 2 times 1 because I wanted for you to notice that you can you can stop at any point and put a factorial in front of the number you have. It would have been the same as 6 times 5 factorial. This is still 6 factorial. This is the same as having 6 times 5 times 4 factorial, isn't it? It's the same because that 5 factorial includes the 4 factorial in it. Okay, so that's why the answer is like so. All right, so that's what you would get. You say this 3 factorial cancel that 3 and then you can evaluate it. Now you can do further simplification. You can say this 2 cancel that 6 away, so 5 times 4 is 20 divided by 1 doesn't change it, end of the answer. So calculating this, you do have to understand it and you do have to do it without the calculator. Alright, so 6 choose 1 is 6 factorial divided by 1 factorial and 6 minus 1 factorial. Now this 6 minus 1 is 5 factorial, so we can write this as 6 times 5 factorial and bam, that 1 factorial is a 1 and that's 5 factorial is going to cancel that from the top, so the answer is 6. Now let's evaluate the other one. 6 choose 5 here. So that's 6 factorial over, again, 1 factorial, 5 factorial. So what's the difference here is that we would have written 5 factorial first and then 6 minus 5 factor 5 and then put the factorial there. This is 1 factorial. And now on the top we can expand it because I don't have room to write yet another one. Just gonna put plus sign, sorry, times sign here and write 5 factorial. This, I've expanded 6 factorial. This is no longer 6 factorial. This is 6 times 5 factorial. And these 5 factorials cancel away. And this answer is also 6. The question was saying comment on your answer. I was looking, what comment you have? Well, these two are exactly the same. So I was hoping that you realize the symmetry between these two answers. This is the symmetry in Pascal's triangle, isn't it? Alright, so next question. Pause the video, have a go at it. Try to use what you just learned, what I did in this line above. You don't have to use a calculator every time. You can do this so that you strengthen your mathematics. Alright, so you would end up with these expressions here that I'm putting. So uh, for this question, 9 factorial factorial times 7 factorial is the same as 9 times 8 times 7 factorial, and then 2 factorial is still 2 times 1, which is 2, and this 7 factorial is going to cancel away the 7 there. So 9, you can still simplify 8 by 2, so you get a 4 and a 1. So finally the answer is 36. So that's why that both give you 36 there. Alright, so have a go at the next question. You don't have to use a calculator. It will be simply 10, the answer there. And the next one is fun. It's like 12 factorial divided by 10 factorial and 2 factorial. Alright, so 12 factorial is 12 times 11 times, I say 11 or 10? No, times 10 factorial. And so the 10 factorial in the denominator cancels away with that. And we left with the 2, which you can, 2 factorial is 2 times 1, which is still 2. So I divide the 12 by 2, I get 66. Okay, so in general, you can just say 10, 100 choose 2 is 100 times 99 divided by 2. I know the answer because 98 factorial, 98 factorial cancel away. Okay, so you can say that's 1, that's 50, plus 50 times 99. Yeah, that's the answer to that question. Okay, so to learn this evaluating this coefficient like binomial coefficients without a calculator somehow, because in your book they do ask you what to do, like evaluate this without the calculator, like figure out what that value is. By the way, you see this notation here in the exercise, where you have like a vector notation. This is a 9 to 7 can be written instead of using C. Some mathematicians write it as a like in a bracket, 9 on top and 7 here. This is not a fraction. Don't There is no line here, so don't confuse with 9 over 7. This doesn't mean 9. This means 9 to 7. So the number on the top must be bigger than the number at the bottom of this notation here. Is this is a still binomial coefficient? So what you see in this exercise is, this means that without the calculator evaluate 6 choose 4. So you're gonna do what I just did on the last page, but without the calculator. Okay, without using a calculator. Now for part question 3, you can use a calculator. All right, so good luck doing this exercise. I'll see you in the next section.